Good day. Myself S. Periyar Selvam, working as Associate Professor, the Department of Food Process Engineering, SRM Institute of Science and Technology, Katangalathur. Welcome to the Department of Food Process Engineering YouTube channel. In this session, I will brief about the importance of food pH for the growth of microorganisms. A knowledge of the factor that influence the growth of microorganisms is essential to understanding the principles of food spoilage and preservations. The important factors that influence the growth of microorganisms are pH, hydrogen ion concentration of food, moisture, water activity or available water of food, oxidation reduction potential of food, and types of nutritional present on the food like a carbohydrate, protein, or lipid. According to that, the microbial growth is going to be vary. The inhibitory substance, that is antimicrobial substance present on the food that influence the growth of microorganism. The next one is the barrier property of food material, that is a structure of the food material that influence the growth of microorganisms. Why hydrogen ion concentration is important in food processing as well as food preservations. Each and every microorganisms they have a minimum, maximum, and optimum pH for their growth. pH of the food significantly affect the growth of microorganisms. For example, if the food is in acid, mostly it's going to be affected by yeast and mold rather than the bacteria. Most of the fermentative yeast they can be grow in the pH of 4 to 4.5. Example, there is a fruit juices. Most of the foods they have a pH of neutral or acidic pH. Fermentative product having a low pH due to the accumulation of acid during the fermentation process. Phlegm yeast they can be grow in the acid food. Example, sauerkraut and pickles. And for example, you can take the pickles and sauerkraut and put one drop of water and allow for few days, and you will find out the growth of phlegm yeast in the top of the pickles or sauerkraut. Usually, bacteria grow well in neutral pH compared with the acidic and alkaline condition. Even though some of the bacteria can able to grow in moderate acidic condition, the proteolytic bacteria can grow in high pH, that is alkaline condition. Example, white of the stored egg spoiled by Salmonella enteritis. The initial pH of the food is important. Sometimes the pH is changed by the microorganisms and make favorable for the growth of other organisms. Example, pickle fermentation. Next, I can move to the buffering capacity of food. The buffering capacity means it's a resistant to change the pH of the food. Example, vegetable having a low buffering capacity, milk having the high buffering capacity. In the vegetable fermentation or pickle fermentation, initially lactic acid bacteria grow and releasing small amount of acid that will prevent the growth of undesirable microorganisms like a proteolytic or hydrolytic microorganisms. In the milk fermentations or curd fermentation, the lactic acid bacteria grow well and producing the high amount of lactic acid in the milk fermentation. Organic acids are more inhibitory than the other acids. For example, acetic, benzoic, citric, lactic, propionic, and sorbic acid that widely used as a astulant or preservatives. Not only the pH suffering the growth of microorganism, it is also impact or influence during the time of storage of food, heating, drying, and other processing of food material. Microbes are classified based on the pH as acidophilic, neutrophilic, basophilic. In acidophilic, the pH ranges between 1 to 5.4, and most of the fungi, that is a yeast and mold, can able to grow in acidic condition, and a few of the bacteria, example Lactobacillus acidophilus, probiotics, and Helicobacterium can able to grow in the acidic conditions. In neutrophilic, the pH ranges between 5.4 to 8.5, and most of the foodborne diseases causing bacteria can able to grow in the neutral pH. Example, Staphylococcus aureus, Escherichia coli, Salmonella typhi, and Salmonella paratyphi. In basophilic, the pH ranges between 7.5 to 11.5, And most of the proteolytic bacteria can able to grow in the alkaline condition, and example Vibrio cholerae. Apart from that, some of the microorganisms can able to grow in the wide range of pH. Example Vibrio parahemolytica. Its pH ranges between 4.8 to 11, and Enterococcus species the pH ranges between 4.8 to 10.6. And some of the microorganisms they have optimum pH of 9, example Alcagen fecalis, and some of the microorganisms even they can able to grow in the pH 12, example Agrobacterium species. If the pH is below 2.5, it is considered as extremely acidophilic. If the pH is above 11.5, it's considered as a extremely basophilic. The ammonia having the pH of 11 and soap having the pH of 10, and egg whites and olive have the pH range of 8, water, milk and meat having the pH range of 7, and melons and cheese is having the pH range of 6. Vegetable bread they have the pH range of 5, and tomato, fruit jam, orange juice they have a pH range of 4, and pears and plum they have the pH range of 3, and vinegar and lemon juice is having the pH range of 2. So based on this, if it is acidic, it's going to be affected by or spoiled by fungi, that is a yeast and mold can able to grow. If it is a neutral pH, then bacteria can able to grow. Some of the food products pH ranges. Dairy product example butter 6.1 to 6.4, buttermilk 4.5, milk 6.3 to 6.5, cream 6.5, cheese 4.9 to 5.9, yogurt 3.8 to 4.2, and meat and poultry products example beef 5.1 to 6.2, ham 5.9 to 6.1, veal 6, chicken 6.2 to 6.4. Fish pH ranges between 6.1 to 6.4, crabs 6.3 to 6.5, oyster 6.5, tuna fish 4.9 to 5.9, shrimps 3.2 to 4.2, salmon 5.1 to 6.2, whitefish 5.9 to 6.1. Some of the fruits pH ranges, example apples 2.9 to 3.3, apple cider 3.6 to 3.8, banana 4.5 to 4.7, fig 4.6, grapefruit 3, lime 1.8 to 2, honeydew melons 6.3 to 6.7, oranges 3.6 to 4.3, plums 2.8 to 4.6, watermelons 5.2 to 5.6, and the grapes 3.4 to 4.5. Some of the vegetable food pH ranges. Example asparagus 5.7 to 6.1, beans 4.6 to 6.5, beets 4.2 to 4.4, broccoli 6.5, cabbage 5.4 to 6, and carrots 4.9 to 5.2, cauliflower 5.6, celery 5.7 to 6, the corn 7.3, and cucumber 3.8, and eggplant 4.5. Egg rolls 6 to 6.3, lentils 6, olives 3.6 to 3.8, onions 5.3 to 5.8, parsley 5.7 to 6, and parsnip 5.3, potato 5.3 to 5.6, pumpkin 4.8 to 5.2, spinach 5.5 to 6, squash 5 to 5.4, tomatoes 4.2 to 4.3, turnips 5.2 to 5. In conclusion, the pH of the food is important factor for the growth of microbes. Based on the information, we predict which microbes can able to grow in the particular food and which cannot able to grow in the particular food. For example, if the food material is in acidic conditions, mostly it is going to be affected or spoiled by fungi, that is a yeast and mold, and some of the bacteria, lactic acid bacteria can able to spoil. If the food is in neutral pH or alkaline pH, mostly it is going to be spoiled or affected by bacteria. With this information, we can go for the preservation or processing of the food material. Based on the information, we concluded the preservation method for the specific food. Thank you for watching these sessions. Thank you.